Hi, I'm Kseniia Shumelchyk, a developer relations engineer on the Android team. It's time to create beautiful apps built for the wrist. With almost 3 times year-on-year activation growth, now really is the time to start building a watch app. Creating a beautiful, power-efficient app for Wear OS means designing it specifically for the watch. Thankfully, Jetpack and Android Studio are here to help. In this talk, you'll discover modern, power-efficient Wear OS app development, along with the best practices to measure and optimize app performance. It's never been easier to make beautiful apps thanks to Compose for Wear OS. Built on top of core Compose principles, Compose for Wear OS provides material components, tooling, and guidance to help you. Apps on smaller devices need to pay attention to performance requirements. We'll cover tools to measure and improve performance while saving power. And lastly, we'll cover Health Services, which enables developers like you to optimize the use of sensors data to easily build health and fitness apps in a power-efficient way. Since last year, we have been working on bringing Jetpack Compose to Wear OS. As you may know from Android mobile development, Jetpack Compose is a modern, declarative UI toolkit that helps simplify and accelerate UI development. It also offers a rich set of UI components that are already compliant with Wear material design, meaning that you can more easily follow the design guidelines. Compose for Wear OS shares all the principles and basic components with Jetpack Compose, although it also has unique components that are optimized for the watch experience. Today, Compose for Wear OS is in beta. This means it's feature complete for 1.0 and has what you need to build production-ready apps. Beta also means API is stable. Moving forward, we will be focusing on performance and polishing existing components for the 1.0 release coming later this year. We have been developing Compose for Wear OS with open source community feedback and participation. Since the developer preview, we have added and improved a number of components such as navigation, scaling lazy lists, input and gesture support, and many more. Compose for Wear OS is our recommended approach for building UIs for Google smartwatch platform. And now is a great time to get started with Compose and quickly bring your app to life or refresh your existing UI. One of the best things about the toolkit is that all components follow material styling and also implement material theming, which allows you to customize the design for your brand. Compose for Wear OS already offers more components that are available with views, and is designed to help you create user experiences that conform to the latest Wear OS design guidelines. We will be focusing today on the major changes we landed for beta release. To learn more about Compose for Wear OS, basic components and principles, make sure you visit our developer site. Compose for Wear OS offers navigation composables, which support the swipe to dismiss gesture out of the box. The concepts are intentionally very similar between Wear OS and mobile, so you can carry over all your Compose knowledge. At the same time, we have Wear OS versions of navigation components to ensure apps feel great on the watch. We have added resistant to swipe to dismiss box, so the motion only happens when swiping to dismiss and not at all in the opposite direction. Let's take a look how navigation works. Swipe dismissible Now controller creates a Wear-specific Now host controller that handles adding of the Wear navigator. Swipe dismissible Now host links the Now controller with a navigation graph that specifies the composable destination that can be navigated. Each composable destination in the navigation graph is associated with a route. The swipe dismissible Now host automatically handles swiping to navigate back and will also animate out-screen content as the user swipes, revealing the destination underneath. For each route, we create each screen's UI with a composable function. Using the Now controller, buttons or other actions on each screen can navigate adding to the backstack and causing different routes to be displayed. Taking a look at how one of the developers we have been working with has implemented navigation in their app. Todoist helps people organize, plan, and collaborate on the projects. As a part of their app refresh, Todoist use Compose to redesign all of their navigation and move away from variable drawer layout towards aware material design guidance for a flatter app structure. You can also see in this video how they have embraced material design for Wear OS by embedding the Wear composable material library and using inline actions. Moving to the next component, ScalingLazyColumn. This is a scaling fisheye list component that can handle large number of content items. It provides scaling and transparency effects and makes it easy to create beautiful, smooth lists on Wear. We made a bunch of improvements to the default behavior of the ScalingLazyColumn to be in line with UX specification, such as updating the scaling parameters, default extra padding, and taking the size from the size of its contents. In particular, we have added a new property after centering. By default, this will ensure that all items, including the first and last, can be scrolled so they are visible in the center of the viewport. You don't need to provide your own content padding in this case, but make sure you set the list header and then show the list items. A new property, anchor type, has been added to the ScalingLazy list to control whether an item's center or edge should be aligned to the viewport center line. These changes also allow to take granular control of scroll events, for instance calling animated scroll to method. In many cases, you may want just use default settings of the ScalingLazyColumn that already does all the heavy lifting for you and guarantee a better default visual effect as most of the viewport will be filled with the list items. If you want to build something a little more custom, you can specify the Flynn behavior. In particular, enable snap support using snap Flynn behavior that will represent a natural Flynn curve with snap to center items as the Flynn decays. The ScalingLazyColumn component has been deployed by the Outdoor Active developer to leverage material-compliant way to render lists on Wear OS. Outdoor Active helps to plan routes for hiking, cycling, running, and other outdoor adventures. Here you can see the implementation for nearby routes, which shows the hiking and cycling routes near our London office. The list items scale down and become transparent as they are scrolled out of the view, and scrolling works with rotary input events. User input components are the ones you have asked for the most, so we have added different composables that you can tailor for your app. Let's start with the picker. Picker let users select an item from a scrolling list. By default, the list of selectable items is repeated infinitely in both directions to give the impression of rotating cylinder seen from the side. Picker has a state that requires to set the initial number of options and optionally the initial selected item, and allows to specify if item will be repeated infinitely in both directions using repeat items property. Option parameter describes the content, and similar to ScalingLazyColumn, Picker has a Flynn behavior parameter, and the default value makes them snap to the closest option when scrolling. We also added a read-only mode to Picker that is useful for screens with multiple pickers where only one picker is editable at a time. In case the picker is read-only, it only displays the current selected option and a label if provided. Here you can see how another developer we have been working with has taken advantage of the picker component. Period Tracker helps keep track of your period cycles, ovulation, and the chance of conception. Period Tracker uses pickers to help users record weight and temperature. They have implemented dual pickers where clicking switches which one is editable and which one is read-only. Next input component is inline slider. Slider allows users to make a selection from a range of values. The range of selection is shown as a bar between the minimum and maximum values of the range, for which user may select a single value. Inline slider is ideal for adjusting settings such as volume or brightness. Here is an example of slider usage. The bar in the middle of control can have separators if the segmented flag is set to true, which is recommended if you have no more than 8 steps. Slider may also take a progression of values as a parameter instead of range and allows to customize increase and decrease buttons. Moving on to our another input component, Stepper. Stepper is a full-screen control component that allows users to make a selection from a range of values. For example, to control the volume of their headphones, the slot in the middle should have a text or chip. If you want to, you can show the current value to the user either with a position indicator or in the text slot. Here is an example of the Stepper component. The range is set from 1 to 10. In the center slot, the text component will display the current value. The dialog component displays a full-screen dialog which will be layered over any other content. It takes a single slot, which is expected to be an alert or confirmation message. Dialog supports swipe to dismiss and will reveal the parent content in the background during the swipe gesture. For consistency with scaffold, our full-screen dialog component displays a position indicator and a vignette. This is a simplified example on how to create a dialog. This dialog is launched from a chip on click and will show the content of the alert. You can find more examples of different dialog usage in documentation. The last component we'll cover is CircularProgress Indicator. This component is used to display progress by animating an indicator along the circular track in a clockwise direction. Progress indicators inform users about the status of ongoing processes, such as loading an app, submitting a form, or saving updates. They communicate an up state and indicate available actions, such as where the user can navigate away from the current screen. There are several options how CircularProgress Indicator can be used. First option is an infinite progress indicator to spin indefinitely and express an unspecified wait time. Another option is to express the proportion of completion of an ongoing task. In this case, you need to provide a progress parameter. CircularProgress Indicator also supports a gap in the circular track between end angle and start angle, which leaves room for other content such as time text if used in full screen. There is no animation between progress values by default, but progress can be animated with the recommended progress animation spec, as in the following example. Make sure to try Android Studio Electric Eel to get the latest features for the best experience developing with Compose for Wear OS. Starting from smart editor features such as autocomplete, editor actions, and Wear-specific composable preview, and up to enhanced debugging support with Live Edit to make Wear OS app development faster than ever. To help you get started with Wear OS, we have added a new project template that includes support for Compose for Wear OS. Let's take a closer look at some of these features. Compose preview annotation allows to set device configuration to watch and to specify one of Wear OS device types so you can instantly verify how your app's layout behaves on different watch shapes and sizes. With a number of improvements available in Android Studio Electric Eel, the Live Edit supports iterative code development for Wear OS. No need to recompile code or install the app. Live Edit provides quick feedback as you make changes in the editor and immediately reflects UI in preview window or running app on the device. If you are building a new app, the best option might be to implement your entire UI with Compose. But if you are modifying an existing app, you can gradually migrate considering a few techniques. A common approach when refactoring your app to a new technology is adopting it in new features. For example, any new screens you are building. In this case, Compose code will interact with the view system at the edges. Compose is designed to interoperate with Android views, so you can combine Compose with your existing UI implementation and perform an incremental migration by having some parts in Compose and others in the view system. For example, using ScalingLazyList to display content inside a view before you can refactor the view model, or any other views that will take a significant effort to port, such as Google Maps view. However, if you migrate lots of individual widgets on a complicated screen, it may cause a lot more work for Compose and slow down your app. Choose sensible blocks to migrate to avoid a patchwork quilt of Compose and views. You can also migrate whole screens to Compose one at a time. Where apps may have less features and simpler individual screens, meaning that migrating your Wear OS app will be hopefully simpler than migrating a complex mobile app. Consider adopting modern Android architecture patterns if you haven't done already. This should simplify migration and only require UI changes. And more importantly, use the strategy that works best for your project. To get started, we have prepared a set of materials from a learning pathway that will take you through the different steps and up to updated design and implementation guidance. Check out the website for more information and join us on Slack to talk to the team and give feedback. Today, we are also announcing the release of Horologist. Commonly, Horologist is a maker of clocks and watches, but in our case, Horologist is a Google open source project which provides a set of Wear libraries that extend the functionality provided by Compose for Wear OS and Wear OS 3. Here you will find the pieces we think you will need to build beautiful, useful, wearable apps. Today, Horologist provides navigation-aware scaffold with time text and position indicator that stay in sync with scrolling and navigating screen changes, beautiful material date and time pickers, and media UI components. Over the time, Horologist will grow with additional features, but we would really like to hear what you need, or consider contributor general functionality useful for Wear developers. Now let's look into performance to make your app snappy. A lot of apps find correlation between app performance and user engagement. Whilst watches have many more sensors than phones, their batteries are much smaller, so focusing on performance is critical from day one. We recommend you to integrate performance testing with your routine development flow. This will help you to identify problems before you publish to the Play Store, and therefore reduce the overall turnaround for eliminating any performance issues with the end users. So here are some simple tips to adopt tools and help you improve your app performance starting now. Tip number 1. Measure performance only with your release builds and never measure your debug builds. Everything that follows applies for the release builds. Run with R8 optimization and minification turned on. Tip number 2. Start with JunkStats library to receive frame timing directly to your app code. Collect details on chunky behavior in your app internal test and build. Get used to seeing what normal for your app looks like. It's as simple as implementing a callback and logging junk frames. Or you can do something more advanced, like collecting frames, periodically uploading summaries to your server, and showing them in a dashboard. Tip number 3. Set up macro benchmark library to measure app startup time. Macro benchmark accurately measures your app startup in various scenarios, from a cold start on first launch to a warm start once fully optimized. This runs as regular Android Studio tests and provide a handy link into the profiler when things looks off. Look at the Android Performance Samples repo to see examples for startup profiling and frame timing. Consider adding your own app trace events for visibility into your app's effect on performance. Tip number 4. This one doesn't require extra work. When a user downloads your app from the Play Store, baseline profiles kick in to optimize libraries like Compose for Wear OS and many other Jetpack libraries automatically. This improves startup performance and reduces junk when your app is downloaded from the Play Store. You can test this locally with macro benchmark to measure the effect, or generate baseline profile rules for your app to further improve performance. For more information on how to create a baseline profile, watch What's New in App Performance talk. But let's talk about your app's functionality. And here we comment for tip number 5. Always build your app to nicely handle offline use. Most user journeys should work well even when network connection isn't available. When only LTE is available, avoid using it to refresh content on every screen or load single images as a user scrolls through a list. Your app needs to handle these offline cases, so be intentional about network requests. Try to prefetch and cache images you may need later in batches when you have a fast Wi-Fi connection and the watch is charging. This leads us to tip number 6. Most network usage optimizations can be accomplished easily with familiar Android frameworks like Work Manager. Instead of immediately running a refresh job, schedule it to run when appropriate conditions are met with reasonable frequency. And finally, Health Services. Use this to efficiently implement health data collection. And now, over to Chad to give us an update on Health Services.
Thanks, Kseniia. Hi, I'm Chad, a product manager on the Wear OS team. And for this last topic, I'm excited to bring you an update on Health Services, which we introduced at I/O last year. Smartwatches have empowered millions of people to take a more active role in managing their health and fitness. At Wear OS, helping developers build great experiences for these users is core to our mission. And thanks to Health Services, it's now easier than ever to build power-efficient apps that utilize all of the incredible sensor data generated by Wear OS watches. Last year, we launched Health Services in alpha, and this year we're thrilled to announce that these APIs are now in beta, with the stable release coming soon. We've worked extensively over the last year with numerous app developers to improve and refine Health Services, and we're super excited to bring this release to the developer community. Before we dive into all the cool stuff in Health Services, I wanted to quickly highlight how it works with Health Connect, which allows apps to store health and fitness data on the user's mobile device. Developers can use Health Services to collect real-time sensor data and then store that data in Health Connect on the user's phone. With user permission, apps can access this data store and sync with each other. Now, on to Health Services. Health Services brings a ton of innovation to the health and fitness developer community, but I want to focus on 3 things in this talk: battery life, developer experience, and future-proofing. Let's start with battery life. Health and fitness tracking requires sensors to be on all the time at high frequency to measure things like workouts, daily activity, and sleep, ideally across multiple days. On older smartwatches, these sensors and their algorithms were managed by each app on the main application processor, which would wake up whenever it needed to process data such as heart rate. This approach had a big impact on battery life. Health Services enables apps to take advantage of modern smartwatch architecture, where much more of the data collection and processing can be offloaded to a low-power processor, allowing the application processor to be suspended for extended periods of time, including while recording an exercise. This means Health Services can consume much less power than alternative APIs while still delivering high-frequency data. Next, I want to say a few things about the developer experience. Simply put, Health Services offers a more modern developer experience for building health and fitness apps. Health Services allows you to write your app once, with the experience gracefully adapting to any differences in the underlying hardware. With the beta release, we're bringing more Kotlin-friendly changes to Health Services and providing 3 different clients that map to the core use cases for health and fitness experiences. Exercise Client handles all of the state management and sensor control for workouts. It provides metrics such as heart rate, distance, location, speed, along with aggregations like total, min, max, and averages. It can also keep track of goals for metrics like step count or calories, and manage advanced features like auto pause. The passive monitoring client provides a power-efficient means to collect the standard all-day metrics like step count and allows apps to be notified of key events such as when a user meets their daily goals. And finally, Measure Client provides a way to get high-fidelity, instantaneous measurements of metrics like heart rate when you need them. Let's take a quick look at just one of these clients, Exercise Client. This snippet demonstrates how easy it is to start an exercise. Note that location, speed, and heart rate are simply data types provided by the platform. Health Services can also calculate aggregated metrics like average speed and total distance. And in this second snippet, having started the exercise, we create an update listener to listen for updates. Both the data and exercise state, like active or paused, are also managed by Health Services. Finally, let's talk about future-proofing. Smartwatch technology is advancing rapidly, and every year there are new sensors and better algorithms on these devices. Health Services is built to grow as these changes are made, allowing your app to take advantage of improvements via an API that is consistent across Wear devices. As new sensors become available on new watches, we'll add new data types to our APIs, and you'll have easy access to those metrics. I wanted to close out with a quote from an Android engineer at Strava on their experience working with Health Services. Their Wear 3 app takes advantage of all of the great features of the APIs we talked about today. And that's the whirlwind tour of Health Services. We're excited to bring these APIs to the developer community, and even more excited to see the incredible health and fitness experiences you'll build with these tools. In this talk, we did our best to equip you for building modern, power-efficient apps on Wear OS. We covered how to use Compose to develop beautiful user interfaces, best practices for optimizing performance, and the usage of Health Services to collect real-time sensor data in a power-efficient way. For more information about building apps for Wear OS, check out developers.android.com/wear. We're looking forward to seeing your apps on Wear OS, and thanks for watching.